What's Gucci, everybody? It's AJ here again, and it is another fine day on Saturday, February 22nd, 2014. Just giving you a date reference. And if you're watching this a year from now, you're 1 year older than when I made this video. Congratulations, even if it's not your birthday. So here is kind of part 2 of threading, and what I want to cover in this video is mutexes. And mutex is short for mutual exclusion, and mutual exclusion means basically only one can enter, is the way I like to think about it. So what is going on here is that in my last video, if you haven't watched it, I suggest you watch it, is that I introduced the concepts of threads. And threads are really cool in that other multiple parts of a program can run while another program is taking its time. But something I also would like to critically add is that if you only have one core, which is another thing in one core in your computer only allows you to run one process. And for the basic concepts of threads, we're only going to be talking about one core, which means only one process can run at a time, and that only one thread can run at a time. So my scheduler is switching between threads, but only at one given time. In our examples, is one thread running at the same time, but it's going to switch between those threads, and then in between those, and then within those processes, it's going to switch in between those processes. And remember, processes contain threads. A process is like Microsoft Word, but there are different threads within Microsoft Word, which may be, changing the font, keeping track of your cursor, and other such things. Okay, so one thing we want to cover now is what happens if you need if you have a problem with your threads. And the way you can have a problem with your threads is, let's say that I'm updating some data. I'm updating some data, and I don't want other threads to access that data while I'm updating it. It's very critical data. Or whenever a thread is updating data, I don't want that thread to be disturbed. And so the reason because I want to do this is I want to make sure that this data I can change this data without being disturbed or without having anybody bug me and maybe ruin my program because they're interrupting my thread. And basically the way you're going to do this is with a mutex. We're going to be able to only allow one thread to be able to access a certain variable or do something at a certain time, so we can allow the threads to kind of work together, but we can make sure that only in some certain cases only one thing is happening at one time. And to show you guys the example here, this is built on the example I showed in the last video, where instead this time I have a pthread mutex-t, which again is derived from the pthread library I have above. And so I have the same thing here where I have a thread2 method and I have a thread1 method. And what I'm going to do here is I'm going to initialize a mutex, which takes my flip done mutex above here. And then I'm giving it a null here. This is if you want to give it a pmutex attribute, that is something I want to cover later, but essentially you can just make it null for now. And right now here is the big meat and bones of what we're about to get into. I have a mutex lock. What a mutex lock does is I am saying that I am going to now lock down this thread. I am going to allow, only one thread to go through these processes, or I'm going to only allow, one thread to only one thread to activate. And if they hit this lock, they only will be able to go, start, the threads will only be able to run again when they're unblocked. So what's happening here is that I am setting a lock on flip done, which is a variable up here. And then in my two methods, in thread 2, I'm locking the thread immediately here. And then in thread 1, I'm unlocking the thread at the end of this method. And what's happening is, in both of these printfs, I'm printing out coin flip. And in thread 1, I'm initializing coin flip to 23. Now the reason because I want to have a mutex is because nowhere else in my program am I initializing coin flip. I'm only initializing coin flip here, which is a global variable up here again. And so I want to make sure that coin flip is initialized by thread 1 before thread 2 interacts with it, so it doesn't, print out a garbage value, or if I was doing other things with null and pointers, or get a seg fault for an illegal, for a null exception. So what I'm going to do here is I'm going to initialize my mutex, which is just, you have to do that. You have to initialize the mutex. You have to lock it. And so what I'm going to say is, okay, all these threads, when they hit this, when they get locked up, I'm going to, not let it continue. So this lock is going to initially be for my main thread. And my main thread is, the first thread when I first execute the program. So the thread, once I go through int main, that's the thread I'm running. And then these two threads are going to be created. And what's going to happen is this thread is I'm going to create these two threads, and then thread 2 is the thread 2 created first, and then if thread 2 is the thread chosen first, thread 1 or thread 2 could be scheduled first. I am going to go into thread 2, and I'm going to hit pthread mutex lock. I am going to lock up. And what that does is it means this thread is locked up until I unlock. And as you can see, unlock is in thread 1. So if thread 2 processes first, I'm gonna lock down here, meaning my thread cannot go further until I get an unlock. And what now happens is, since I'm unlocked, I'm now going to schedule a look at my next thread, which is thread 1, and I'm going to set coin flip to 23, so that ensures that 23 coin flip will be initialized to 23. I'm going to do a printf, and then I'm going to unlock. I'm gonna unlock my thread, my mutex, meaning, okay, you can now pass. When I lock, I say you shall not pass, and when I unlock, I say you shall pass. You can now continue on your way, so this thread can finish, and then the rest of my program can finish. And then for safety, I destroy my mutex when I'm done with it at the very end of my program. So right now, I'm just going to prove this to you guys I'm going to show you that now I'm going to run this program a million times. I'm going to just keep on clicking play on this program here, and I'm going to keep on getting thread 1 and then thread 2, and it's always going to be the same dandy good value. It's always going to be thread 1 executes first and then thread 2 because of the way I'm locking and unlocking, which is pretty cool. So you can use this to preserve special data, because something also special about threads is that they share global data. Threads share both threads, even though you don't want to think of threads as different processes, as different programs. Threads share these values. They share this array. They share this mutex, and they share all these things. They don't share local variables. So they don't share, if I had like int I equals 1, they actually do not share that. That is just special to thread 1. But they do share global variables, and they do share static variables as well, so static local variables. But so it's very important that if you're accessing a global variable, you may want to make a mutex so that they don't get defunct or out of order. And so that's all for today, guys. I hope you had a great day, and I hope Gandalf lets you pass and you know how to use your threads now. I'll see you guys later, and I'll post this code on GitHub.